Hi everyone, it's me again, back with another problem. Today it's going to be number 2 here. And this problem is, what is most nearly the slope of the line tangent to the parabola y equals 12x squared plus 3 at a point where x equals 5? Now the first thing that I would do is take the derivative of y with respect to x, which would reveal 24 times x. Then I would plug 5 into x, which would equal 120. So B would be the answer here. Now you ask why. So the slope is a rate of change element. And just so happens, if you take the derivative of the parabolic equation and plug the point where the line will be tangent to into that derivative, that will give you the slope of that line because it's the rate of change. Now, to get a little more into the details and a little step-by-step action here, over here I went on ahead and drawn the x and y axis and a parabola here represented by this line, and this dashed line is the tangent line to that parabola at a specific point as indicated with the dot here. Now this is the starting equation for the parabola. So the first step is to take the derivative of y with respect to x. So I tried to break down the derivative process here. So when you take the derivative of the exponent of a variable with an exponent, which all variables and constants have an exponent, but you take the exponent, you subtract it by 1, that will be the new value of the exponent for that variable. You take n, which is the original exponent, and multiply it through to the constants of that variable. Here, for the constant, you have m minus 1. In this case, m equals 1, which would be the value here. There would actually be a 1 here. So just a placeholder exponent. So then, with that, this will be the new solution. So it was 2, now it's 1. It's typically not shown. This becomes 0, because the new exponent on the constant would be 0. Alright, so now the second step is to plug in the point for the newfound equation that we just got from the derivative. So plugging that in, that gives you the slope. As I was saying before, the derivative is a rate of change value. So this would be the rate of change of the new tangential line. This is how it's found. So you're wondering, well, is that going to work? Is that really accurate? How do I even know if that's accurate? Okay, well, there's a couple different ways you can go about doing this here. So this is the equation of a line, and we're missing the y-intercept. We don't really know what the y-intercept of this line is. We can take a couple guesses, and I can already tell like it's going to be lower, but so I went ahead and made a table here. So you can just go all the way down till you get to 0 and just subtract it from the previous value, subtracting the slope. And that will reveal what b is going to equal. Or you can use your handy dandy calculator. So what you want to do in order to get this to show up correctly, you want to press Data, and this is where you plug in your variables. As you can see, I've already plugged them in here, but you just hit Enter on the variable, or the option here, and you hit your value, which will be 5 in this case. The next one's going to be 4. Hit that. Come over here, do the same thing, because these are the values. Then you go to, you just want to go X out of that, and you want to hit second. Then you go to Data again. This pulls out the statistics and registry options. And you scroll down until you get to option 4 here, which is linear regression formula, also known as the equation for a line in the slope-intercept form. Hit enter. Make sure you choose your data correctly. X data would be your L1 table. Y data is your L2 table. Frequency is 1. Don't worry about that, leave that to no. Then you just go to calculate, and voila, here's your values. There's your A and your B, A being your slope, so 120 right here, and then B equaling negative 297, just as we found here. So yeah, a very useful tool, very helpful. Hope you guys learned something, and looking forward to the next video. Thanks guys, bye.